Welcome, friends. So, let us start with the new topic, that is the yield criteria. Yield criteria, or the failure criteria, also we can say. Actually, in my previous video, when we were discussing about the stress strain diagram, then also we have discussed a few things related to this yielding, or what is the upper yielding, lower yielding, and what exactly the yield point is. So these things we have discussed in that video also. So here, if any system is under different applied load, so then basically at which point the material get start yielding, so that is the point of discussion. So as from the yield point, actually the from the yield point, the plastic deformation starts. Okay, up to the yield point the material is under the elastic range, and after that yield point, the plastic deformation starts. It is a combination of stresses, okay, which will govern the initiation of yielding. So for that, so the first criteria for that is, so it assumes that the yielding can occur in a three-dimensional state of stress. One, the root mean square of the differences between the principal stresses reaches the same value, okay, which it has. So when yielding occurs in the tensile test, for that let us consider a beam. Here it is, okay, and the tensile stress is applied here, sigma x. So in the three dimension we are considering, so that we can represent here, if this is our x, this is y, and along this is z. So we may also map these x, y and z axis. So the mapping for that can be like, if we have the 1 2 and 3, like this also we can map this. So for that, as this we may consider, let the y be the stress, at which yielding begins in simple tensile test. Okay, for 1D tensile test, we can say, so for that, in that condition, so sigma x, maybe for the major principal stress it can be written as sigma 1, or it is y we have considered, and this is for the major principal stress. Okay, major principal stress, and the other principal stresses, so that can be like sigma 2, or the sigma 3 can be considered as a 0. So therefore in the tensile test, the yielding occurs. Okay, So what will be the, let me is this. So by the definition, as I told you, so the root mean square of the differences of principal stress. Okay, so what will be the root mean square of the differences of principal stress? So what that can be written as, if it is sigma 1 minus sigma 2 plus sigma 2 minus sigma 3 plus sigma 3 minus sigma 1 square, and mean of that root mean square of the differences of the principal stresses can be written like this, because sigma 2 and sigma 3 is 0, and tau xy, that is also tau yz, that is also tau zx is equals to 0. So considering these values, so as we will put the value of sigma 2 and sigma 3 also 0, and what will be the result now for from this equation can be written as, on solving, so it is what it is equals to 1 by 3, and y minus 0 square, because we have considered sigma 1 is equals y, sigma x or sigma 1 that is equals to y we have considered, plus sigma 2 minus sigma 3 whole square plus sigma 3, and that we are just putting the values here, not we need to write the similar step. So here it is 0 minus 0 square, okay, plus 0 minus y square, like this we can say. So here it is the square, and finally what will be the value, it will be 2 by 3 y. Okay, so that is equals to this step. So if this root 2 will be on the left hand side, either 1 by root 3 will be cancelled out. So finally we can say that the 1 by 2 sigma 1 minus sigma 2 square plus sigma 2 minus sigma 3 square plus sigma 3 minus sigma 1 square is equals y. Okay, like this. So this is the von Mess's yield criteria. Okay, it can be modified for known principal axis. Okay, so for the known principal axis we can modify this equation. For known axis, it can be modified. So what will be the result then it is 1 by 2 sigma x minus sigma y square plus sigma y minus sigma z square plus sigma z minus sigma x square. Okay, plus uh, that is our 3 tau xy square plus 3 tau yz square plus 3 tau zx square to the power half. Okay, that is equals to y. Okay, square root of that. So for the plane stress, okay, for stress what will be that, sigma 3 is equals to 0. Okay, then the Mess's criteria is represented by an ellipse in the sigma 1 sigma 2 plane. Okay, for in sigma 1 sigma 2 plane we can represent the uh, Masses criteria. So let us draw an ellipse for that, and for that we need to again have some space on this board. So for that, if we can have these different axes, like this is sigma 1 plane, sigma 2 plane. Okay, in this direction x direction sigma 1 plane, and y direction sigma 2 plane. So we will represent it by an ellipse. Okay, so for that, here we will have the conditions. So for any combination of sigma 1 and sigma 2, if the points lie on the ellipse, on this surface, on the ellipse the points lie, so the material will start yielding. So okay, up to this is the condition. So this is the first criteria, and for the second criteria, let me raise it, and for so it assumes that yielding occurs whenever the maximum shear stress reaches. Okay, so the value it has been yielding occurs in the tensile test. So let us draw the Mohr circle. So the if here is the Mohr circle, sigma tau, and if the Mohr circle is like this, so what will be the this point will represent the sigma 1, and what will be the maximum shear stress, so that can be represented by, if this is y, the you can say the uh, radius of this Mohr circle is y. So then the maximum shear stress can be represented as its this is the maximum shear stress. If we can represent by y the diameter. Okay, so for that, maximum shear stress we can say, so that is equals to y by 2. This is the circle. Okay, the radius, sorry, the radius of that is y by 2. If this is y, so this is y by 2. Okay, so for that, we can say that tau maximum, that is equals to sigma 1 minus sigma 2 by 2. Okay, and that is equals to y by 2. So now this, that is the radius of the circle. Okay, this is the radius of a circle. uh, so we can say the maximum shear stress, criterion, or the Tresca criterion. Okay, so this can be represented by the hexagon. A hexagon will represent the Tresca criteria. So for the plane stress, the boundaries of the yielding or Tresca can be understand here. So in place of the von Mess criteria, so what will be the changes in the Tresca criteria? So again we need to draw this for this von Mess criteria. If this is the ellipse, okay, so this is sigma and sigma 2, sigma 1 and sigma 2, it's sigma 1. Okay, and for that, if this was the point, so we need to draw the hexagon. it's a pentagon, I think. It's not a hexagon. So here we need to make some correction. So here it will be like this. So now, although it's not accurately, ellipse is not formed. So okay, so this circle will represent the mesh criteria, and these points will represent the Tresca criteria. Okay, so here we can say it is the Masses criteria. Okay, and this will represent the maximum shear stress criteria, or Tresca criteria. Okay, so this is for the yielding. So the two different types of the criterion we have discussed in this lecture. Thank you.